So in this video, we are going to talk about writing a matrix given a system of equations. So matrices are often used to represent and solve systems of equations. It just makes it a little bit easier to look at by not having to look at all of the variables. You just have all of the coefficients and constants in this matrix, and then sometimes it's just easier to manipulate and solve. So when you're writing a matrix given a system of equations, each row represents an equation, and each column represents one of the variables or a constant. So in order to ensure that you have everything lined up properly, you need to make sure that your equations are all in standard form. So that means your variables are on the left and your constants are on the right, and all of your variables are kind of lined up. So you don't want to have your x first in one equation and your y first in another equation, because then you're going to end up with mixed variables in the same column. An augmented matrix includes the coefficients from the left-hand side of the equations along with the constants from the right-hand side. A coefficient matrix only includes the left-hand side of the equation. So let's look at these. The augmented matrix is really useful if we're going to be solving these. So number one, we're going to write the augmented matrix for the given system of equations. And then number two, we're going to write the coefficient matrix. So the augmented matrix includes the constants or the solutions. The coefficient matrix only includes the coefficients of the variables or the left-hand side. So for the augmented matrix, we first want to make sure that we have all of our equations in standard form. So notice we have the x's first, the y's second, and then the constants are on the right-hand side of the equal sign. And so we can write the matrix. So row 1 is going to be equation 1. Row 2 is going to be equation 2. And then you're going to line it up so that the coefficients of x are going to be in the first column, and the coefficients of y are going to be in the second column. And then you can use a straight line to kind of separate. It's kind of like the equal sign. It separates the coefficient matrix from the solution or the constant on the right. So the last part is the constant term. Okay, so in equation 1, we have -2 is in front of the x, and we have an 8 in front of the y, and then the constant is 7. So -2, 8, 7 is the first row. And for equation 2, we have a 3 in front of the x, a -1 in front of the y, and a 5 as the constant on the right. And so this is the augmented matrix for that system of equations. So 2 equations, that means 2 rows, and then we have 2 variables and a constant, so that's 3 columns. All right, number 2 is write the coefficient matrix. Remember that that is just the coefficients of the variables, so that's just going to be what's on the left-hand side of the equal sign, or the left-hand side of that straight line from the augmented matrix. So -2, 8, 3, -1 would be the coefficient matrix. All right, let's look at the next ones. So given these 3 equations, we want to write the augmented matrix and write the coefficient matrix. So the augmented matrix, the first thing we want to do is make sure each equation is in standard form. We want the variables to be in the same order. So generally that's x, y, z, and we want the constants on the right. So the first equation is in x, y, z, and then the constant is on the right. The second equation, though, we have an x and a z, and then we have the constant that's on the left. That's a problem. We need to move it over. And there's no y term. So you're going to have to be mindful of that. So we're going to have x plus 3y minus 8z is equal to 9, so that doesn't change. But the second equation, we have negative x plus 3z minus 5 equals 0. We really want this minus 5 to be on the right. So I could add 5 to both sides, and that would give me negative x plus 3z is equal to 5. Now I don't have a y term, and if it helps you, you can put a 0y. So if you wanted, you could write it as negative x plus 0y plus 3z is equal to 5. That way you remember that that 0 is a placeholder for the y. So negative x plus 0y plus 3z is equal to 5. All right, and then the third equation, we have 12x plus 8z is equal to 5y. So here, notice that the y is on the right. We want the y, anything with a variable should be on the left. So we want the y on the left. Notice we don't have a constant term this time. So that means we're just going to have a 0 on the right-hand side. And then we want to put these variables in order. And so I usually do alphabetical order, so X, Y, Z. That's kind of traditional. But you just have to make sure they're all in the same order for sure. So 12x minus 5y plus 8z equals 0 is the third equation. So now all three equations are in standard form. So I'm ready to write the augmented matrix. Since I have three equations, I will have 3 rows. And since I have 3 variables and a constant, that's going to give me 4 columns. So for the first row, 1, 3, negative 8, 9 are the numbers that I will use. The 1 is the coefficient of the x, the 3 is the coefficient of the y, the negative 8 is the coefficient of the z, and the 9 is the constant. And then we're going to do the same thing for equation 2. So I will get negative 1, 0, 3, 5. And then equation 3, 12, negative 5, 8, 0. And so we're not asked to do anything else yet with the matrix other than just write it. So for any system of linear equations, you should be able to write a matrix that corresponds to that. Okay, so an augmented matrix or a coefficient matrix. The coefficient matrix, remember, is just the left-hand side or the coefficients of the variables. So that would be 1, 3, negative 8, negative 1, 0, 3, and then 12, negative 5, 8. So some of the wording or the examples, I used the OpenStax College Algebra, the 2nd edition. Please, if you need more information or more examples, go to this URL and use this textbook. It's a great free resource available to everyone. Okay, so the next thing we're going to look at is what happens if we're given, let me make sure that's the last page. It is. All right. What happens if we're given a matrix and we want to write the associated system of equations? So we're basically going to go backwards from the above examples. So now we're given the matrix. We want to write the system of equations. So the first thing I would do is kind of look at it and see how many equations I would have, how many variables there are, etc. So we're going to assume it's in kind of the traditional format where the first variable is x, the second is y, the third is z. This straight line up and down is an equal sign. And then the right-hand side is the constant term. Since we have 3 rows, we have 3 equations. So the first row is going to be 2, and since that's in the first column, that's an x, plus 1y, and so we don't need to write the 1 in front of the y, we just write y. Then we have a negative 3 in the z column, so that'll be minus 3z is equal to 1. All right, same thing for the second row. So we have 5 first, so that'll be 5x minus 1y, so just minus y, plus 0z. That means I don't need to write the 0z, is equal to 4. So it's really just 5x minus y equals 4. And then we have 2x plus 6y plus 5z is equal to negative 6. And so that is the system of equations associated with that matrix. And so we can do the same thing with number 6. So number 6, we only have 3 columns here. So x, y, and then the straight line indicates the equal sign. And then we have the constant term on the right. And there are only 2 rows, so that means we'll have 2 equations. So this will be 3x plus 5y is equal to 2. And then we have negative x plus 2y is equal to 7.